In this video, we're going to review the machinery of row reduction and how we turn a general matrix into a matrix in row echelon form, which is good, and reduced row echelon form, which is best. So the rules of the game are that if somebody gives you a matrix, a row operation is something that you do where you can rescale a row, that is, multiply a row by any non-zero constant, or you can add a multiple of one row to another row, or you can swap two rows. These are called row operations. Okay. And the goal is if somebody gives you a matrix, you want to apply a bunch of row operations until the matrix either becomes in row echelon form or reduced row echelon form. So what row echelon form means is that some of the rows might be nothing but zeros. If you have a row that is nothing but zeros, it has to be at the very bottom of the matrix. Every other row has a first non-zero entry. The first non-zero entry is called a pivot. So this is a pivot, this is a pivot, this is a pivot, this is a pivot. That's the first non-zero entry of a row. Row echelon form means that each pivot is to the right of the previous pivot. So you have this staircase. Echelon basically is French for stairs. That you have the staircase that you go to the right until you get to the pivot of the next row. Then you go to the right until you get to the pivot of the next row. Go to the right. Now I drew it where it's 1 to the right. You could also have something where you go 2 to the right, or 3 to the right, or 4 to the right. Okay. Now reduced row echelon form it has to be in row echelon form, but then it has two extra conditions. We have to rescale the pivots, rescale the rows so that the pivots are all equal to 1. And what's more is above each pivot is nothing but zeros. So here's a 1, above it is a 0. Here's a 1, above it are 2 zeros. Here's a 1, above it are 3 zeros. And we're going to see that we can put any matrix in reduced row echelon form, and furthermore, that there is only one reduced row echelon form corresponding to that matrix. We call that the reduced row echelon form of the matrix. So as an example, let's start with the following matrix. We're going to systematically do row operations to turn it into row echelon form. So the first thing we do is we say, hey, we want all the pivots below, here's a pivot. That too is a perfectly good pivot. We want all the other pivots to be to the right of it. So we have to turn this into a 0, this into a 0, and this into a 0. We do that by adding multiples of the first row to all the other rows. So we subtract the first row from the second row. Pop. And then to get rid of this negative 4, we add twice the first row to the third row. And then to get rid of the 4, we subtract twice the first row from the last row. And there we go. We have a pivot, and below that pivot is nothing but zeros. So far, so good. Now the next thing we do is we look at the next pivot. The next pivot is this 3. And we're going to clear out the things underneath the 3 by subtracting off multiples of the second row from things below it. So here is the matrix that we just wrote down, and this is the pivot that we're working with. Now this is already 0, so we don't have to do anything to this row. This is 3, so we subtract the second row from the third row, and boom. Now we have our pivots, and we're almost in row echelon form. The only thing that stops us from being in row echelon form is this third row, which is nothing but zeros. We said that those were only allowed at the bottom of the matrix. So we swap the third row with the fourth row. And there we go. And now we've got our matrix in row echelon form. Here's our staircase. We go 1 step to the right, then 2 steps to the right. But it's not in reduced row echelon form. To put it in reduced row echelon form, we want to make the pivots equal to 1. We want to make everything above the pivots equal to 0. So to make the pivots equal to 1, we have to rescale our rows. So if we have a 2 here, we want a 1, so we just divide the first row by 2. We have a 3 here, we want a 1. we divide the second row by 3. Divide the first row by 2. Divide the second row by 3. Leave the third and fourth rows alone. Now we've got our pivots equal to 1. And now we want to get rid of the terms above the pivots. So we work from right to left. Looking at the last column, we subtract multiples of this row. We subtract 3 times the third row from the second row. We add the third row to the first row. And really all we're doing is we're getting rid of the 3 and the negative 1. There we go. Finally, we want to get rid of everything above this pivot. So we add the second row to the first. And there we go. Reduced row echelon form. The pivots are all equal to 1. The spaces above the pivots are all equal to 0. And we